Hello everyone, I'm Professor Abdul Karim from University Science Malaysia, and in this lecture I'm going to talk about edible oil refining with focus on the crude palm oil, which can be obtained from the mesocarp of the oil palm fruits, and also the crude palm kernel oil. And we are going to discuss about the refining of this crude oil to produce the refined oil and the production of the various products from the palm oil. So in this picture, a sample of crude palm oil in the bottle. You can see that it has a very dark orange or dark red color and is quite viscous. And in the bottle, you can see that the crude palm oil has been separated into two layers. The bottom layer is the sediment, or sometimes called a food, and on the top layer here is the oil. So in the crude palm oil, basically it contains around 95% triacylglycerols or triglycerides. This is the actual part of the oil that we want to separate from the crude palm oil. And there are about maybe 5% or less of the non-triacylglycerol fraction, which consists of a mixture of phosphatides or the gums, free fatty acid, FFA, oxidation products, and other things. So basically the aim of edible oil refining or crude palm oil refining is to remove all these components down to a very low level. In this slide, you can see the list of non-triacylglycerol component in the crude palm oil or in any crude vegetable oil. So for example, we have a free fatty acid or FFA. This is in the crude oil usually present at around 3 to 5%, and in the refining we want to reduce to a very low level, maybe less than 0.1%. And we have partial glycerol, mono and diglycerols, which are the results of partial hydrolysis of the triglycerides in the crude oil. Then we have phosphoacylglycerol or phosphatides. These are what we call gums in the oil, which give a viscous property to the crude oil. And other components such as pigment, sterol, tocopherol, oxidation products, protein, and the trace elements. The trace elements such as copper and iron, these are actually pro-oxidant, which can promote oxidation in the crude in the oil. So we need to remove this to avoid oxidation of the oil. And we have other components such as waxes, hydrocarbons, moisture, dirts, and other components. So in essence, we can say that the aim of refining is to remove those components that I mentioned in the previous slides that can have adverse effect on the overall oil quality with the least possible damage to the triacylglycerol. In this picture, you can see various palm oil products at various stages of refining. So for example, on the left here, this is a crude palm oil. Then after the bleaching stage to remove the pigments, you can see the color is lighter. So this is a bleached palm oil. Then in this picture, this is actually after the bleaching and deodorization to remove the fatty acids. You can see the color is much lighter. And this one is actually the oil after bleaching and after the deodorization to process to remove as much as possible the color, the free fatty acid. So this is basically the refined oil, and this is actually the byproduct of the refining process, which is the fatty acid distillate, which can be processed further to produce other oleochemicals and to produce a soap. Okay, this is a schematic flow chart to show the process in the refining of crude palm oil. So we start with the crude palm oil. Then for the refining process, in general, we can divide the process into physical refining, basically by using high temperature steam distillation and chemical refining, which uses chemical by using alkali or the caustic solution to remove the components that need to be removed during the refining process. So in physical refining, we need a step called degumming to remove the gums, the phosphoacylglycerol or phosphatides. Then the next step is the bleaching process to remove the pigment, and deodorization process. This is the steam, high temperature steam distillation to remove the volatile fatty acid and reduce it to a very low level. So the product of the physical refining is called refined bleach deodorized oil, RBDO, and the byproduct is a free fatty acid distillate. In chemical refining, we use a caustic solution. So the free fatty acid in the crude oil will be neutralized by the alkali neutralization process, and we get a byproduct called a soap stock, and this will be separated out from the oil by centrifugation. Then we can also add the earth bleaching. This is a bleaching step to remove the pigment or the color of the oil. Then the deodorization process to remove the free fatty acid, and the product of this alkali neutralization is called neutralized bleach deodorized oil, or NBDO. At some stage after the bleaching process, we can take the oil and for modification process, for example hydrogenation and interesterification. But after this process, for example after hydrogenation, there are probably some free fatty acid that need to be removed by deodorization process. And the other modification process, for example fractionation, can be done on the refined oil to produce the refined bleach deodorized styrene fraction, which is the high melting fraction, and refined bleach deodorized olein, which is the low melting fraction. Okay, now let's look at more detail on at the various unit operation in the refining of crude palm oil. The crude oil usually is stored in the tank, and during storage it will separate into two layers. So the sediments or the oil insoluble part, sometimes called food, can be separated out from the oil. Then the degumming process will remove the phospholipid, which is the gums, the viscous component in the oil, and also other components such as sugars, resins, proteinaceous compounds, and trace metals in the crude oil. In the alkali neutralization process, we add the caustic or the sodium hydroxide to neutralize the free fatty acid and remove also other components, pigments, and some gums, sulfur compounds, and other oil insoluble and water soluble compound. Then the washing step is to wash the soaps that is produced as a byproduct from the neutralization step. Drying stage. Drying is used to remove the water, which sometimes is added during the degumming process. So the water have to be removed to a very, very low level, because water can promote hydrolysis of the triglycerides in the oil. Bleaching is a process to remove color, the pigments which give the color of the crude oil. And during bleaching also we will remove other components, for example the oxidation products, more trace metals, and the trace soaps, which results from the neutralization step. Then the filtration step, basically to remove the what we call spent bleaching earth, because bleaching earth actually exists in the form of powder or particles, insoluble particles. So after the bleaching process, the filtration will remove the residual bleaching earth as much as possible from the oil. Deodorization step is basically the final step in the refining. This will involve high temperature process to remove the volatile fatty acid down to a very, very low level, and also to remove some residual mono and diglycerides and other small compounds, aldehydes and ketones, hydrocarbons, sulfur compounds, and the product of pigment decomposition from the oil. In physical refining, the impurities removed during the refining process also fatty acids, mono and diglycerides, aldehydes and ketones, hydrocarbons, and so on. These are basically the same components that will be removed if we use a chemical refining process. And another step typically used in the refining is called polishing. Basically, the objective is to remove as much as possible the insolubles, the trace oil insoluble from the oil. Okay, now let's look at some of the differences between alkali refining and physical refining. So let's start by looking at the criteria that we can use or when we can use alkali refining. Alkali refining is more suitable for crude oil which contain relatively low content of free fatty acids, because if the amount of free fatty acid is high, then it will react with the alkali and form a significant amount of soap stock, and the soap stock can actually entrap some of the oil and increase the oil losses. So with low amount of free fatty acid, low amount of soap stock will be produced, and therefore this will reduce the oil losses. So in the alkali neutralization step, a lot of free fatty acid and the phosphatides or the gums will be removed. Alkali refining does not normally require a separate degumming step, because during the alkali neutralization step, a significant amount of gums has been removed at this stage. One of the major differences between alkali refining and physical refining is the production of soap stock in the alkali refining process. The soap stock actually results from the reaction of the free fatty acid and the alkali, and this is usually removed by centrifugation operation. Alkali refining is also said to be more adaptable to crude oils of low quality, which means that if the crude oil contains a significant amount of gums or phosphatides, the alkali refining can be adjusted to remove the gums as much as possible without much oil losses. Okay, now let's look at the physical refining. Physical refining is in general more suitable for oils with a high amount of free fatty acid but relatively low content of phosphatides. So our palm oil actually meet this criteria, and also coconut oil. Free fatty acids are generally very volatile and can be removed by using a steam distillation. But unlike alkali refining, where the degumming step may not be necessary, in physical refining, the degumming step is very, very important. For example, we can use the acid degumming step to reduce the phosphatides or the gum to a very low level, with usually less than 20 ppm phosphorus. And because we use steam to remove the free fatty acid, no soap stock is produced, unlike in the alkali refining, because in alkali refining the free fatty acid is reacted with the alkali to produce a soap stock. So in general, we can say some of the advantages of physical refinings. We can get a higher oil yield, and we can get reduction in chemical usage, and also less problem on the waste treatment. However, physical refining is said to be less adaptable to crude oils of low quality, which contain high amount of phosphatides, because we need to remove the gums in the degumming process, which can cause or increase the losses of the oil. In Malaysia, actually, physical refining is more popular. So actually, there are more than 95% of Malaysian palm oil using physical refining as opposed to alkali refining. So next time, if you happen to pass through a palm oil refinery or palm oil factory, probably you will see this tall structure or tall column here. This is actually the deodorizer column, which actually uses steam distillation principles to remove the free fatty acid from the crude palm oil. And this is how it looks like from inside the refinery plant.